In this lesson, we're going to discuss a buffer overflow. Now, a buffer overflow occurs when a process in a program stores data outside the memory range allocated by the developer. Now, this begs the question, what exactly is a buffer? Well, a buffer is simply a temporary storage area that a program is going to use to store its data. Let's pretend that you have a glass sitting on a table. It can hold a certain amount of water, right? If it's designed to hold 16 ounces of liquid, for example, and you try to pour 20 ounces in, well, that cup is going to overflow with water and the table is going to get wet. Now, in this example, the glass is our buffer, and when we overflow it with our data, in our case water, the extra is going to spill out onto the table and make a huge mess. Buffer overflows inside of the technology space can also create a really big mess for us. In fact, 85% of the data breaches were caused by buffer overflow attacks being used as the initial attack vector. So it's really important that we take a look at how a buffer overflow attack actually works. Now, let's pretend that you wanted to store my phone number into your contacts list. Here in the United States, our phone numbers consist of 10 digits. The first 3 digits are for our area code, which represents the city that we live in, and the last 7 digits represents the person's unique phone number. But before we had cell phones, you would simply pick up the phone and dial 7 digits on your phone because the telephone company assumed you wanted to place a local call within your own city or area code first. So let's pretend that the person who designed the contact list application on your phone decided they wanted to save some memory space, and so they wanted to use the smallest buffer possible. Therefore, they're going to decide to use an 8-digit buffer because they're going to assume that you don't need to store an area code because all you're going to do is make local calls all day long. So let's go ahead and store a made-up phone number of 555-1234 into our 8-digit buffer. We're going to call this buffer A. Now, when I do this, you can see that it takes up the first 7 boxes labeled 0 through 6 because computers always start counting with 0 like you learned back in your CompTIA A+ studies. Now, what happens if we try to enter a number that's a little bit longer though? Well, buffer A isn't the only memory buffer that your contact list application can use. Right after A comes B, and after B comes C, and so on. So let's consider how we could store a longer phone number. For example, let's say you're out on vacation at the beach and you meet somebody, but they don't live in your city. Well, in this case, you need to store the area code and the phone number, like 410-555-1234. Now, this includes the area code for Annapolis, Maryland, and we now have 10 digits that we have to store. But each of our buffers is only 8 digits long because our programmer didn't quite think through all the different types of phone numbers that one person might need to store in their contact list. So our contact list application tries to store this 10-digit number inside of an 8-digit buffer. But the last 2 digits are going to overflow out of buffer A and go into buffer B. That is exactly what happens with a buffer overflow. Now, you may think, that's not such a big deal, Jason. Why is that a bad thing? Well, to explain that, we have to get a little bit technical, so bear with me here for a moment. Each program is going to reserve a chunk of system memory when you first start it up and it tries to run. This allows it to have a place to store data that it needs to use during its processing, and we call this area a stack. Now, a stack is a reserved area of memory where the program is going to save the return address when a function call instruction is going to be received. Here is an example of a stack that's organized as first in, last out. Basically, this means that the first thing that's being placed in the stack is going to be the last thing to be removed, and the data is going to be filled from the bottom of the memory all the way up to the top of the memory. And actually, when you look at this, the bottom is actually on the top of our screen, and the top of the memory is actually at the bottom of our screen. Now, I apologize for this because you think that it looks upside down, but in actuality, this is the standard convention that we use in the IT and technology space. So I wanted to introduce it to you here so you won't get confused later on in your studies. Now, if an attacker tries to place too much information into that stack, or they change the values of that return pointer, they can actually carry out an attack. And this is what they're attempting to do with the buffer overflow. They're attempting to overwrite the return address of the pointer so that it will point to a different place in the stack where they've already placed their malicious code. That way, when a non-malicious code is being run, like Microsoft Word, and it hits that return pointer, it can then return to the attacker's malicious code, such as the /bin/shell code shown here, and this will give them a shell or command prompt on the victim system where they can now perform a remote code execution using that shell. When an attacker is able to do this, this is known as smashing the stack. Now, this occurs when an attacker fills up the buffer with a NOP or a non-operation instruction. So that way the return address may hit one of these NOPs or NOPs and then continue all the way down until it finds the attacker's code and begins to run it. When this series of NOPs is hit by a non-malicious program, because the attacker has already filled up the buffer with all these NOPs and return address to their malicious code, this is known as a NOP slide. Now, the NOP instruction essentially is an instruction that tells the computer to do nothing and simply go to the next instruction. And it will continue to do this and slide all the way down until it hits a new instruction or return pointer. And in this case, it's the final return pointer that causes the program to branch over to that memory address where the attacker placed their malicious code. Now, one of the mitigations against a buffer overflow attack is the use of something known as the address space layout randomization, or ASLR. Now, ASLR is a programming technique that helps prevent an attacker's ability to guess where the return pointer for a non-malicious program has been set to call back to by randomizing the memory addresses used by our well-known programs, such as parts of our operating system or things like Microsoft Office. Now, ASLR was actually introduced all the way back with Windows Vista as a way to prevent these buffer overflow attacks. But there are methods used by attackers these days to bypass the address space layout randomization, or ASLR technique. This includes things like side channel attacks. Now, like I said, this is a very technical concept, and it's not one you need to understand in depth for this particular certification exam. If you move on to some penetration testing certifications later on, like the CompTIA Pen Test Plus exam, then you're going to come back and look at buffer overflows in much more technical depth. But for this exam, you just need to remember that a buffer overflow is going to be used to put more data into memory than it's designed to hold, so that the attacker can try to get their malicious code to be run. This is done in an attempt to overflow the buffer for that non-malicious program so that the attacker can get their malicious program into memory and allow it to be run instead. So keep this in mind for the exam.